Welcome to my class. In this video, I'm going to teach you step by step how to balance a complex redox reaction. Then before we talk about the question on the board, what is redox reaction? Redox reaction is a type of chemical reaction whereby oxidation and reduction occur simultaneously. The question on the board is talking about balancing of complex redox reaction in an acidic medium. A redox reaction can be balanced in an acidic medium, then it can also be balanced in a basic medium. But in this video, we are going to look at balancing of complex redox reaction in an acidic medium. Let's go. The question says, balance the following redox reaction in an acidic medium. We have reaction between Fe2 plus MnO4 minus equal to Fe3 plus Mn2 plus. Then what is the first step that you need to take? You are going to assign oxidation number to each atom that has changed. Assign oxidation number to each atom that has changed. So let's do that. What is the oxidation number of Fe2 plus? That is the charge on it. The oxidation number is 2 plus. Then when you look at this place, we have MnO4. We have two atoms, two different atoms. But at this side, we have Mn2 plus, that is manganese. It shows that it is only manganese that change. It is only manganese that change. So you are going to calculate the oxidation number of manganese out of this ion. So let's look for the oxidation number of manganese. That is Mn plus, how many oxygen atoms do we have? We have 4 oxygen atoms. Then equal to the charge that is on it. This minus means -1. Now, what is the oxidation number of oxygen or the charge on oxygen? That is 2 minus. Then how did I get this 2 minus? Oxygen is in number 8 in the periodic table. So when you write the shell electronic configuration of oxygen, the first shell will take 2. Then the second shell will take 6. 2 plus 6 will give you 8. Then don't forget that the second shell will take the maximum number of 8 electrons. So it needs 2 more electrons. It needs 2 more electrons. That is why we are having -2. It needs 2 more electrons. So that's why we are having -2. So the oxidation number of oxygen or the charge on oxygen is -2. So let's proceed. Now, we make Mn the subject of the formula. Since we are looking for Mn, that is the manganese, -2 times 4 will give us -8 equal to -1. Then make Mn the subject. So Mn equal to -1. Bring this -8 down to this side. That will be +8. So -1 plus 8 will give us +7. -1 plus 8, that is +7. The oxidation number of manganese is +7. So let's come to this side. Fe3 plus, the charge on iron is 3 plus. So the charge is the oxidation number. So the charge on manganese is the oxidation number, that is 2 plus. So we have taken the first step. So the next step now, we are going to divide into 2-half reaction. You divide this equation into 2-half reaction. Then you divide it into oxidation half and reduction half. So we are going to look at the substance that oxidized and the substance that reduced. So let's connect ion 2 to ion 3. From +2 to +3, there is an increase in oxidation number. From +2 to +3, there is an increase in oxidation number. Then what is oxidation? Oxidation is increase in oxidation number. It shows that ion 2 oxidized to ion 3. So let's take the first half reaction. That is Fe2 plus, then equal to Fe3 plus. Fe3 plus. Then the second half reaction from +7 to +2. So this one is oxidation half. This is oxidation half. So let's take reduction half. from +7 to +2. So there is decrease in oxidation number. Then reduction is decrease in oxidation number. So let's take manganese. MnO4 minus 2, Mn2 plus. So this is reduction half. This is reduction half. Then what is the next step to take? You are going to balance each atom. You are going to balance each atom from the first half reaction and the second half reaction. So let's consider the first half reaction, that is oxidation half. Now we have one atom of iron. We have one atom of iron. When you are counting the number of atoms, don't count charge. Don't count their charges. So we have one ion at this side, at the reactant side. We have one ion at the product side. So oxidation half is balanced. Now let's look at reduction half. We have one manganese at this side, one manganese at this side. But oxygen, we have oxygen at this side, but there is no oxygen at the product side. So we are going to balance oxygen. We add oxygen to the product side. So to balance oxygen at the product side, you add water molecule. Add water molecule to get what? To get oxygen at the product side. Now the number of oxygen atom at the reactant side will be the number of water molecule that will be added to the product side. So let's do that. So we have MnO4 minus, then equal to Mn2 plus, then you add water to get oxygen. Since we have 4 oxygen atoms, so you are going to add 4 molecules of water. So from these 4 molecules of water, you'll be able to get 4 oxygen atoms. But something has been added, that is hydrogen. Something has been added, that is hydrogen. So we have added 8 hydrogen atoms. 4 times 2 will give us 8. We have added hydrogen atoms. Now you come to the reactant side and add hydrogen ion. Then don't forget that what is an acid? An acid is a substance that produces hydrogen ion. So to prove that this chemical reaction is an acid or it is balanced in an acidic medium, so you add hydrogen to this side. Now we have MnO4 minus. We have 8 hydrogen at the product side, so you are going to add 8 hydrogen ion to the reactant side, that is plus 8H plus, then equal to Mn2 plus, then plus 4H2O. So you can see that atoms, the number of atoms balanced. Then what is the next thing to do? We are going to balance the number of what? The number of electron loss or the number of electron gain.